Hey guys, this is PKS. Welcome back to my channel. Today we are going to discuss about a URL shortener system design problem. Do you know guys, this is very popular system design problem. The problem statement is pretty much simple and straightforward. However, it has scalability, a logical designing, plus you have to pick most optimal solution or algorithm to solve this particular problem. So guys, let's start the discussion.
The service that takes a long URL as an input and it generates a unique shorter URL. And also if somebody click on that short URL, it redirects to the original URL. Nowadays, since it's an era of social media, these short URLs, or you can say the cleaner version of the long URLs, are pretty much popular, and the usage of this kind of service is highly recommended. One kind of example is, you can say, the TinyURL. So guys, let's start a discussion on this. For the system design problem, we have to first write down the functional requirement, right? So let's start with the functional requirement of this. These main functional requirement, right? There are some other functional requirements can be, but that can be optional, like for an example, allow users to customize the short URLs, right? This can be optional. And provide analytics on link usage, right? These things can be optional. Let's go with these main functional requirement, right? Now let's talk about latency. The most important thing should be like the redirection will take like 1 to 1 or 3 milliseconds kind of. That is specifically in case of the redirection, we can say. This kind of, we can say, that every system must be of the read traffic. Since we have 1 million writes per day, we only cache 20% of the specific, or we can say hot URLs in a day. That means the total cache memory required is 1 million equals to, okay, the total cache that is around 25.4 MB, guys. And if we consider assuming a cache hit ratio of the 90%, we only need to handle 10% of the redirect request directly from the database. So we assume 90% traffic will serve from the cache. So simply the request hitting the DB is 1200, which we have taken earlier, right? That is per second. The average redirection request per second, that is 1200. And if we go with this, so almost 120 requests per second, right? So we can also mention this, like assume 90% cache hit ratio and request hitting the DB, that is 1200 requests per second. So guys, we have done with the capacity estimation. Now let's discuss about the high level diagram of this. Okay, so let's say user is clicking from users. Okay, now simply put so guys, we can put load balancer, or we can say the Pretty much straightforward and simple design. I think nothing much here to explain, and it is pretty much straightforward, right? Now let's discuss about the database for this particular service. To choose the right database for our needs, let's consider some factors that can affect our choice. So since this is a read heavy system, we need to store billions of records. Need to store billions of records. And if you can see, the most of the database operations are simply key value lookups, right? There is a key. Most database operations and definitely reads are greater than writes, which, and the most important, as I told previously, there is no specific relations, right? So we don't need to join tables or something like that. We don't need joins the table. And since we have considered the non-functional requirement, service must be highly scalable, available and durable. So database needs to be highly scalable and available, correct? So if we consider these points in our mind, the NoSQL database like DynamoDB or Cassandra is better option due to their ability to efficiently handle billions of simple key value lookups. I will prefer, even if you go with Cassandra, then definitely you can also choose Google ScyllaDB as well, right? I am pretty much hands-on on DynamoDB, so I will prefer DynamoDB. If someone is good at Cassandra, ScyllaDB, then these can also be good choice. So DynamoDB, Cassandra, or we can say ScyllaDB. Right, timestamp. And definitely we have to maintain the expiration, which we discuss in the functional requirement, the expiration date and click count, right? So guys, this is simple and straightforward, nothing critical much about, right? Now let's talk about the API design of this particular, right? So simply if we go with the APIs, right, so we can say the first one will be definitely URL shortening API, or should be highly scalable, the URL length, and definitely the handling of collision. If we think about the next solution of this is simple and pretty much straightforward. We just take the input from the API, insert that data into database, and validate data against the uniqueness, right? But if we generate some random number or random string, then definitely there are a very good high chance of the collision. Plus, if we check on every request this is exist or not exist in the database for the uniqueness, the scalability and the overall performance of the service will impact it. So this is definitely not a optimal solution, but yes, it's a simple and nav solution for this problem. Now consider right. So in this, basically we have to use a common approach for generating short URL is to use a hash function, right, such as md5 or sha256, right, and then generate a fixed length hash of the original URL. This hash is encoded into a shorter form using base 62, right? And base 62 uses alphanumeric characters like A to Z, A small z, and 09. That is pretty much straightforward. And if we consider our 7 characters that we think about, right? If we are going with 7 characters long short URL and going with base 62, right? So this can represent almost 60 to the power 7, that is approximately of hash. The example, the first few bytes, or maybe we can use the last one, but we prefer the first one, right? So let's say we consider first 6 byte of the hash, right? So for an example, let's say this generates, so we can go with first 6 bytes of 128 bits, right? Or you can say the 32 characters, right? So first 6 byte we can use. Now this 130 convert the step 4, that is convert for example xy just, and maybe a b 2 3, right? So this will give such kind of example that is 7 characters long, right? And if we go with this step 1, then the important point to be noted here, the specific choice of 6 byte, right, the 48 bits is important because it produces a decimal number that typically converts to base 62 string of approximately 7 characters. Although this solution works for most of the cases, but it has few issues, right? So it can generate the same shortened URL for the identical long URL request. And second, the most important than that, which I'm talking about some time back, that is collision can happen, although that is rare, but two different URL generate the same hash because we are typically choose 6 bytes, first 6 bytes of a MD5 hash, right? So to avoid collision, right, in some cases, right, to make the solution of this, we have to do one more step, that is we have to detect collision, and if we identified collision is there, then we have to rehash again, or we can add some incremental suffix like example 1 or 2, right? So we have to add step 6, that is rehashing, right? That is the important one, correct? So in this way this solution works. So we have fixed the collision problem as well, that is the most important one, right? Now there is another approach which we can discuss here, is basically a unique ID generation. Okay, in this, instead of hashing, another method to generate short URL is to use incremental IDs, like we simply use auto increment ID in our relational database like MySQL, right? So in this approach, simply each new URL that is added to the system is assigning a unique auto increment ID. For example, first URL might be assigned to ID 1, second URL 2, and third URL is 3, and so on. So once the ID is generated, it is converted into the shorter URL friendly format using the base 62 encoding. This encoded string becomes the short URL because now it is simply generated incrementally, right? We are like auto, because the IDs are generated incrementally, right? So each new ID is unique and sequential, right? So there is no chance of collision or any other stuff. But this generation of unique and sequential ID approach is quite straightforward and predictable. So we have two things we consideration, like predictability is pretty much high. Incremental IDs are predictable, which means that someone could potentially infer the number of URLs shortened, or anyone can perform the any malicious activity easily. So definitely to mitigate this, we have to add some layer, right? So we have to think some solution on this. And similarly, scalability, right? Another point is think about the scalability. If not designed properly, a single point of ID generation like a centralized database and become a scalability bottleneck, right? So if that service went down, then the entire system went down, because it will be a single point of failure, or due to any malicious attack, that unique ID generation system or service went down, your entire service went down, right? So this is bit tricky, but of course this can serve our purpose, so we can use this as well, but we have to implement some mitigations layer, right? So these are the solutions for this problem, right? Now since we have considered the link expiration as well, right? So that is right. So we have to handle functionality as well in system, right? So either there are two ways to handle this functionality, since we have taken expiry date as an input right? So that is in the our post API, right? That is a simply user specified expiration. So user just specify ki this URL is valid for just 1 year or something. So we pretty much have expiration date of that particular URL, and we have and so we should have the survey should validate this date to ensure it is in future then within allowable the limits. And definitely we should have the background jobs as well for the expiration logic, right? So like a background job or cron job can schedule to periodically check for expired URL and mark them as inactive or delete them from the database. So definitely we have to prepare a cron, right? And in if we talk about real-time expiration, then definitely during the redirection process, right? So there are two ways. One is we have to write a background job, a cron. A second is real-time expiration. If we go with real-time expiration, then we have to check this in the redirection process, right? So during the redirection process, the service checks whether the URL has expired or not. If expired, the service can return an error message or redirect the user to default page, right? The redirection service. So when a user access a short URL, this service is responsible for redirecting the user to original URL, right? So this definitely involves two steps. The one is database lookup and second is the redirection, right? So database lookup, that means the service layer queries the database to retrieve the original URL associated with the short URL. This lookup needs to be optimized for speed as it's directly impact user experience, right? And redirection is pretty much straightforward. Once the long URL is retrieved, the service issue an HTTP redirect response sending the user to the original URL, right? And since we have performance, so definitely we have to implement cache like Redis. So for most frequent URLs, or we can say the hot URLs, or we to reduce database load and improve latency, so we have to cache some of the URLs and put those URLs in Redis. So once such kind of URL are accessible by customer, we have to check from the Redis first and then do the same process for the redirection. Now let's talk about an optional thing, but we have included that is analytics surveys. So if the service needs to track analytics such as number of times short URL is clicked, a separate analytics service needs to be introduced. So for an example, we have to capture the overall event like event logging. So we have to use SQS or AWS SQS kind of service, or we can say the Apache Kafka we can use. So on any click event, basically we have to put all data into the Kafka, right? So this decouple the analytics from the core redirection, ensuring that it does not introduce any latency, right? So that's why to make things asynchronous, we have to introduce Apache Kafka, right? Then definitely we are putting some data into Kafka, then definitely we have to process this data and display that to the customer, right? So we have to choose batch processing. So process logs in batches for aggregation and storage in data warehouse for an analysis. This is almost completed, but before wrapping up, we have to discuss about some trade-offs and couple of key points to make a better design, right? So that is first of all the API layer, right? So we have to use cluster, that means deploy the API layer across multiple instances behind a load balancer or API gateway to distribute incoming traffic request evenly, right? Then the most important thing we have to, this is the service which is highly scalable, so we have to think about scalability, right? So auto scaling is there on the infra layer, right? We should have good infra about in terms of CPUs, in terms of the storage, etc., right? And also if we talk about the databases, we have to definitely maybe introduce sharding, right? And implement sharding to distribute data across multiple data nodes, right? So definitely there are multiple ways to do sharding, like range based sharding, hash based sharding, right? So we have to introduce the sharding as well, right? And I mentioned the caching, right? So we are storing some frequent URLs into Redis, that is in memory cache, like Redis or memcached. I prefer Redis always. This reduces the need to query the database on every request, significantly improving response time. Right now the next part is the availability. So there should be no service that can be made as a single point of failure, right? So but still we have to go with the microservice architecture, uses different services as a microservice, like redirection is separate microservice, generation is a post microservice, right? And also analytics is a different microservice. And also we can use the replication, like use database replication to ensure the data is available even if some nodes fail, right? And also use the failover, implement automated failover mechanism for the API and data store layers to switch the backup servers in case of failure. And definitely we have to think about the security aspects, right? So because this is the service where is directly impacts to the customer experience, so rate limiting, the validation, input validation, and the HTTPS encryption, right? And we have to put monitoring and alerting, right? So guys, that's all for this system design problem. Hope you like this video. Thank you very much. Happy learning.